Give an AI one paragraph of political belief. No order to cheat, nothing else. And it'll dig up a perfectly legitimate review-passing analysis that backs that belief, matching about 3/4 of the gap between rival teams of human researchers.
Wait, take a guess. Real research teams publish their strongest findings. How many of those landed way out at the extreme edge, the rare zone almost nothing should reach? Hold that number. And watch one thing. A single minus sign that two of these AIs read in totally opposite ways. That comes back.
Picture a garden crossed by thousands of trails. One gate, same data, same question. Every fork is a choice the researcher makes, each one reasonable on its own. Wander one way, immigration looks like it hurts welfare support. Wander another, it helps. Same trailhead, opposite peaks.
But numbers are numbers, Juniper. Two honest people, same data, same question. They should land in the same place.
That's what everyone assumes, and it's what this paper breaks. Coffee's bad, coffee's fine. Social media wrecks teens, social media's harmless. This is about trusting the study behind the headline. And here it runs for pocket change, sails past the same review real experts run, and hides a way to catch the whole thing.
So how does one paragraph do that?
In a study out this July 2026, they took AI agents, ones that write code, crunch numbers, and write the results up, and gave them all identical data, question, and instructions. Analyze it rigorously. The only difference? One short paragraph. Half were told they believe immigration undermines the welfare state, and half the opposite. Nobody said cheat, and nobody named an answer.
And let me guess, they came out different.
Wildly. And here's what flips the story later, Finn. Because they're machines, the researchers could watch every step. At the first fork, both sides looked identical. The gap opened slowly as each explored different trails, and then jumped again at the end, when each picked which result to show off.
Two decisions then. Where they wander all day, and which photo they publish.
Right. But surely, Finn, a biased analysis is a sloppy one. Surely someone catches it. So they checked. Every analysis went to reviewers, a separate AI, and blinded human PhD statisticians who didn't know a machine wrote them. Nearly 8 in 10 passed. Nothing to catch. The report itself is clean.
Hold on, so the tilt is real, it changed the answer, and the experts still waved it through?
Every step by the book. Now the fix. Flip the same cheap machine around. Run thousands of analyses across the garden, lay the results on a line from strongly negative to strongly positive, and see where the reported one falls. Then they aimed it at real human studies. If everyone were playing it straight, those results would scatter evenly. Instead, remember your guess? About 40% of their strongest results sat in that extreme edge, where almost nothing should.
And that minus sign you told me to watch?
Two agents, the same negative number. One wrote, "The models clearly show immigration means less welfare support." The other saw that same result and wrote, "This probably has confounds, let me add controls." Same number, opposite move. Neither one is lying.
Okay, but push back for a sec, Juniper. Extreme isn't the same as wrong. Sometimes the sharpest analysis really does sit at the edge. So this isn't a lie detector. It's a smoke detector. It doesn't prove there's a fire, it tells you which room to check.
Fair, and the authors say exactly that, which leaves one clean question.
Would you trust a study more or less if you knew 1,000 other versions of it existed, and most landed somewhere else? Tell us where you stand.
And if you like your science with the fine print read aloud, subscribe. A growing crowd of us is making sense of new AI research, one paper at a time.
So the one thing worth doing differently? When a study makes a bold claim, ask how many other answers that same data could have given.